lost my... Oh, here it is. So if it's okay with you guys, I think I'll let you turn these in next Tuesday in the interest of avoiding hurricane-related last-minute announcements that will make me angry. I mean, if we have class Thursday, great. If we don't, so be it. Either way, do Tuesday so that we don't have to think about the hurricane rain issue. Don't expect this is going to happen every time, but this time I think there's, you already got one. There's an extenuating circumstance, yeah? You can work together on this, but make sure that your thoughts are your own at the end of it, yeah?
For this version that you said, when you said to copy the problems, you're wanting us to copy, like...
Problem 1, find the orthogonal trajectories of 2xy equal to 1, et cetera, et cetera. Yeah. But, so, hey, we got a few minutes, right? Like 5 minutes, is that right? So let's see here. Let me think about whether or not I want to say anything about these problems. I think problem 1 is self-explanatory. You guys can figure that out. Problem 2, I worked the same problem just now with a v squared here, right? So you ought to be able to do that one. It's just like what I did in class today. This one here, so what method would you use to solve problem 3? Integrating factor sounds like a plan. It is linear, so yep, that should do it. This is absolute value, right? That's a case-wise defined function, right? So that means, I say find a continuous solution. That means what you have to do to solve this problem is to solve dy dx equal to, either plus or minus x minus 3 as appropriate, where the origin is. Solve that. Figure out what that does, as you get into the other case of this function. You'll actually have to continue one case to the other. It's a two-step problem. I'll let you think about that. We haven't done anything like this, but it's just a straightforward application of what we've already done. It's just you have to think about what continuity means and what this is case-wise defined to mean, right? It's either x minus 3 or 3 minus x, depending on where you are. Okay. Find the explicit solution of this guy. Oh man, that looks like yet another what problem? Man, we're in reruns already. That's just problem 3 again. That's the integrating factor method, right? But it's a little bit different. Failure to appreciate laws of logarithms, properties of logarithms will hurt you there. You must review your laws of logs if you have not remembered them. Find the implicit solution of this guy. Yep. So, yep. Well, I won't say much more about that. Also, find the potential energy function for the conservative vector field. Huh. Huh? 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 Huh. Do not treat these two questions as if they're somehow divorced. They're not divorced. They're quite related. But also bear in mind that I did ask for potential energy, not the mathematical potential. Those do differ by a sign, do they not? Problem 7 is a substitution problem. There's one of these in the notes. I did not cover it in class, but it's kind of similar. You make a v equals y over x substitution. You ought to be able to work that out. Problem 8, consider the vector field. Find the level curve, which serves as an integral curve for f through the point p naught. And I'm just singling out, there's one point which we shouldn't try to find the level curve through because it's, unpleasant. and that's the point 1 comma 0. 1 comma 0 makes this have division by 0 here. We should avoid that. But otherwise, you should be able to find the level curve. Now this, you should go back to, what, the first lecture, the second lecture, I think? I think it was the first lecture. We found a condition without time, a differential equation we could solve without time to find the level curve. That's one you probably should use, right? Problem 9, find the parametrization of the path through that point. Again, I'm trying to avoid the point which makes the vector field be 0. That's troublesome. Minus a half, minus 4/3, that makes it 0. I want to avoid that point. I think something weird happens there. Otherwise, I'm pretty sure there's an integral curve. And you're supposed to find the parameterization. So you need to go back and solve dx dt equal to that, dy dt equals to that. 2 differential equations, 2 unknowns, but they're uncoupled. It's pretty easy to solve. I think they're both, I want to say they're both integrating factor method. I think you have integrating factor method for x, integrating factor method for y, and that'll give you the parameterization of the path, which serves as the integral curve def. And on the other hand, you could just find the level curve by using the same trick that we used to solve problem 8 for part B. So part B is just solving like dy dx equals to something over something. I won't say what. You figure that out. And then finally, problem 10, since I did talk to you guys about differential forms for a long time, I felt like I should ask you a question. This is a relatively benign question. If we have this one form, a dx plus b dy plus c dz, where a, b, and c are smooth functions, that just means you can differentiate them. Show that the exterior derivative of the exterior derivative of alpha is 0. All right? And when you look at that, you should be able to identify that as one of the, vector identities that we learned in calculus, or you should have learned in calculus 3. You may not have. It's fine if you didn't. But anyway, you should be able to interpret your calculation as it relates to curl, gradient, and divergence in Calc 3 and the appropriate vector field or function. That's it. So, I mean, it'll take you a little bit, but there's nothing here that's insurmountable, yeah? And you can work together. Oh, I'm sorry, I forgot to show you the existence and uniqueness theorem, but you can read it, right? Right? Yes? I'm going to go on next class. I'm going on to like higher order stuff, so thanks.